This is the screencast for section 3.8, derivatives of inverse trigonometric functions. Okay, so first of all, a quick note about the derivative of inverse functions. If f is differentiable at every point on an interval I, and the derivative of f with respect to x is never 0 on that interval, then f has an inverse, and that is differentiable at every point f of I. So meaning the original function, if you look at the slope or the derivative at the x value a, let's say that slope was 3/2, a rise of 3, a run of 2, well then the derivative, its slope or derivative at f of a is going to be 2/3, positive. It's not the opposite in reciprocal, it's just the reciprocal. Now like I said, we're going to be looking at inverse trig functions in this section. And you will have to memorize the derivatives of the inverse trig functions. Now, understanding where they came from makes memorizing them a lot easier. Otherwise, it's just this weird, I don't know, rational function put together. So if you take some time, go through, I've kind of added in some steps here that will explain how the derivative of inverse sine of x is 1 over the square root of 1 minus u squared, and you know that square root of 1 minus u squared, as you can see from over here, kind of comes from a Pythagorean identity that you are familiar with. Now I know from understanding the proof that I just pointed out, as well as memorizing the derivative of inverse sine, that the derivative of inverse sine of u is going to be 1 over the square root of 1 minus u squared times du dx. Well, in this case, for example 1 here, u is x squared. So to take its derivative, I'm going to have to do 1 over the square root of 1 minus u, which is x squared, but that's u squared, times then the derivative of u, which is 2x. And you can, of course, put that in the numerator and make that the square root of 1 minus x to the 4th in the denominator just fine. Then now try problem number 3. It's going to ask us to find the derivative of y with respect to the appropriate variable, in this case is t. U, in our situation here, is going to be square root 2 t. So the derivative of y with respect to x is going to be 1 over the square root of 1 minus that u squared, so square root of 2 t and then squared, times the derivative of u. So the derivative of square root 2 times t is just square root 2. And again, I can write that as square root 2 all over square root 1 minus, let's see, that would be 2t squared. And then, as always, you can check. So I graphed I put in y1 the original problem. In y2, I told the calculator to take its derivative. In y3, I put my derivative in, and I graphed and saw that they were the same.